Hello everyone and welcome to day 15 of Kaggle's 30 days of ML challenge. And today we don't have a tutorial, we have the competition for the next 15 days. It's a regression problem, so take a look at the competition. Yeah, there's a lot of Kaggle swag prizes. The evaluation is RMSE, so yeah, it's regression problem. What I'm going to do is I'm going to create a new notebook first. And the first thing we will do today is we will create the folds. So what do I mean? So whenever we start with a machine learning problem, it's best to create folds that you will be using throughout, especially in Kaggle. So I'm going to import NumPy, I'm going to import pandas, and I'm going to import from sklearn, import model selection. Okay, so now we will be dividing our data into folds, and that's all we are going to do, and based on that we will make a submission today. So I have the data frame, so let's call it df underscore train, and we will just read the data frame pd.read csv, input 30 days. So you can also press tab. So let's see if it works. Yes, train.csv, and I have read the data now. So my data looks something like this. And here you can see you have a lot of categorical columns, you have some continuous columns, you have an ID column, and you have a target. Okay, so if you want to plot the target, you can quickly do df underscore train dot target dot hist. And now we can see the target. And once we have the target, what can we do is we can, since it's a regression problem, you can just simply use KFold. All you need to do is you have to see if the distribution of data is same in each fold. If it's not, use Shoegaze rule, as I mentioned before in one of my one of the days of 30 days of ML, and that's something you can use, but today we will just be using KFold. So I will initialize KFold as KF. So this is a different way of using KFold from train test split. And I will do model selection dot KFold, and here I can write n underscore splits, and these are the number of splits I want. So usually 5 splits are perfectly fine. How much data do we have? df underscore train dot shape. So we have 300,000 samples. So we will be using 20% of that for validation. Okay, so 5 splits is perfectly fine. You have a lot of data. So now I do n splits equal to 5. And what I can do is I can go over. So I can write for fold, comma, train in the indices, comma, valid underscore indices, in enumerate. So I will just write enumerate. Here I can also write shuffle equal to true, and random state equal to 42. In enumerate, kf dot split x equal to train x equal to df underscore train. Okay, df underscore train. And now I can print fold, comma, train underscore indices, comma, valid underscore indices. If I do that, see what it prints me. So this is your fold value. These are the indices that you have to use for training, and these are the indices you have to use for validation in the first fold or the 0th fold. Okay, so now we want to use this data inside our data frame. So we will write, we don't need train indices, we just need the validation indices, and we will write df underscore train, all rows, valid indices, comma, one thing I missed here, we will also create a new column, and we call it KFold. KFold, and assign the value of -1. So now when df underscore train, now when I print df underscore train, all values in KFold are -1. Okay, so now I do df train valid indices and KFold column and assign it the value of fold. Awesome, we got an error, unhashable type numpy array. Df underscore train valid indices KFold equal to fold. We forgot dot lock. Okay, so now I have df train dot head, and here I have KFold column, which has the fold values. So if I just want to do like df underscore train dot KFold dot value underscore counts, it's giving me 60,000 for each because there's 300,000 samples and you have done 5 folds. So it has divided all your data in 5 different parts. And if we want to see like, okay, for df train dot KFold equal to 0 dot target dot hist. So if you do that, you will get the histogram of the target. So 0, 1, 2, 3, and 4. Okay, so they look very similar to each other, so I guess we will be fine. So I'm going to remove this, I'm going to remove this, I'm going to remove this one. We don't need this, we don't need this, we don't need this, we don't need this one, and that's all we need. And this notebook we are going to run only once. That's very important thing. That's something you should remember. dftrain.csv. I will call it train folds.csv, index equal to false, and I will save the data. And whenever I have to use the data, I will not be using this train.csv, but I will be using this train folds.csv. And how we will do that, I will show you just now. So now let's call my notebook create folds and let's save it. Okay, it's again in edit mode. Okay, let's wait for some time and it will create the file. So now I have the notebook here, and here I have train underscore folds.csv, and that you can find in the output. So here, now let's go back to the competition and let's see the getting started code. So someone is already using XGBoost, but let's not do that, or let's try doing that. And let's see this one, and let me create a new notebook. So now in this new notebook, I have to add the data, but I didn't download the data or create a data set out of it. So let me just quickly download the data from here. So this is the train folds.csv that we created. So it should have a KFold column, and the kernel is public, so you can download it if you want. So let's save the file. And now here we go, and here we will add the data. So you don't have to do that. You can just use the dataset that I create, but I will be adding the data here, and it will be called 30 days KFolds or just folds. Okay, so now I can just add the data that I have created, train underscore folds, and it's here. Okay, so now it takes a while to upload, but you don't have to worry about it. You can just find this data set. I will make it public and you can just use it. But you should know how it's created. So if you want to change the random state, or if you want to make more folds, you can do that. Then you upload it this way. Okay, so let the dataset be created, and the dataset is going to be public, as you can see here. So when you add the dataset 30 days folds, you can find it here. Okay, and inside that you have train underscore folds. Okay, so let's remove all this and import pandas. What else do we need? Let's see what we have here. So in the code section, let's start with this notebook. So we have pandas. So they did ordinal encoder. We don't need plain test split anymore. Random forest means square error. Okay, so I'm doing this really very quickly, and this is the day one baseline, but we won't be doing it this way from tomorrow. I will explain more about what we are doing, and we will change the way we are writing the code a little bit. So import pandas as PD. Sorry. Okay, so now it's going to. So now what I can do is I can already start writing some code. So let me read the CSV file. So df, just call it df, and it will be read from my dataset. So this one train underscore folds. So 30 days folds slash train underscore folds dot CSV. And your test dataset is df test pd dot read underscore CSV. And here you have from the actual dataset, from the competition dataset. So 30 days of ML test.csv, and we can also read the sample submission. Sample submission, and sample submission usually has the same format as df underscore test. So that's the test dataset. By format, I mean it has the same order of IDs. Okay, so and we can check that df underscore test. We have the IDs 0, 5, 15, 16, 17, and sample underscore submission. Should have the same order of ID 0, 5, 16, 17. So this is the Kaggle standard thing. So that's why I didn't check it properly. And now what we can do is we can see what's happening here. So they loaded the data, okay, created features and stuff. And they fit the model, ordinal encoder, model fit transform x. Okay, if cat is in column names, then it's a object column. So that's all that you have to remember. And then they fit the random forest model. So here I can write for fold in range 5. So I have 5 folds 0, 1, 2, 3, 4. Xtrain will be df dot KFold not equal to fold. So take everything which is not equal to fold, and xvalid will be df KFold equal to fold. So everything in the given fold, and I will also add reset index drop equal to true. Okay, and we will enhance the code a lot tomorrow. And now what we have to do here is let's just do some copy pasting today. So we take all this. So we have the object column, okay, and what it says for column in column for column in features dot column if cat in col, or we can just write xtrain dot columns, remove it, and ordinal encoder. So it says x object columns ordinal encoder dot fit transform. So here it will be xtrain for us and x valid for us. Yeah, one more thing is you should apply the same transform on the test set. So just wait for it. And here it's xtrain and X valid. Okay, object columns, object columns. So far so good. It's directly from the exercises. And here we also create, we write df underscore test, object columns, ordinal encoder transform, df underscore test, object columns. Okay. So now it's going to give me some predictions, and we can see how good the predictions are. And this will give us RMSE score. Squared equal to false is going to give us RMSE score. So we fit the model on X train, and okay, we forgot Y train and Y valid. Okay, no problem. Y train is X train dot target. What was it called? Targets. Yeah, it's called target. Okay. And one more thing that we have to do is we have to see which features are useful. So useful features. C for C in df dot columns if C not in. So we don't want to have ID column. We don't want to have target column, or we don't want to have KFold column. And this applies same for all types of data, the validation data or the test data. So it should have the same columns. Okay. So now you got your X train, and here I can write Y train and Y valid equal to X valid dot target. And now I can write, let's call it useful features. I don't need to calculate it all the time, right? So I can just move it here. And here I can write X train is X train and useful columns, useful features, and same for X valid, and same for this will be X valid, and here will be df test, so to df underscore test, useful features. Now this is also something that we don't have to do in the loop all the time. So I can just remove it here and put it here. Okay, but I need to create all these all the time because it's different data sets. It's different folds. Okay, let's see if this works. So pred's valid, and this should be X valid. Y and Y train. So we named it differently. Okay, object calls is not defined, so we forgot to run this. Okay, let's read the data. Let's have these object columns, and let's run this. And let's see what happens. Model is not defined. Obviously, model is not defined. Okay, we also need to define the model every time. So instead of adding random state equal to 1, I can say random state is fold, the value of fold 0, 1, 2, 3, 4. And we also need to import. So this is imported. Okay, everything looks okay. And let's see. So here it gives me some error. Found unknown categories in column 0 during transform. Okay. So the problem here is we didn't copy df test, so it's changing in different iterations. So if we just add copy, x test equal to df test dot copy, then it will work fine. So that was our mistake that we did, but good that we saw it. So now it's training the model. I can also add verbose equal to 10 to just to estimate how much time it's going to take the model. Okay, so we have n jobs equal to 1. We can improve the training speed by adding n jobs equal to -1. So let me cancel the run again, and we run it again. So let's see what it's doing now. So now it's building 4 trees at the same time. So it should be 4 times faster. We have 4 cores. Okay, so this seems like a very, very slow model to me. So we have to do something else. We should probably try to use XGBoost regressor. Okay, or maybe it's finishing. So it will take some time, but it will finish. So I will let it run without verbose with njobs1. I will just remove this and this. And here I'm also printing fold, comma, mean squared error. Okay, and in each and every iteration, I'm generating the validation prediction, but I can also generate test spreads. And each iteration will generate me new test predictions. So let's call this will be X test. And let's say I have a list, and here I say final predictions. This is a list of values, and we will append, so test underscore spreads. So we will say final underscore predictions dot append test spreads. So in each fold, we will be appending 2 final predictions. So let me just see if it's correct. Dot append test spreads, and now I cancel the run, and I will just let everything run till it finishes this part, and this is going to take a while. So let's start from here. Okay, so now it's running, and you can grab a coffee. The random forest on this data seems to be taking a huge amount of time. So what we are going to do is we are going to cancel the run, and instead we will try to use XGBoost. From XGBoost, import XGB regressor that we saw in the last lesson. Okay, so we have the XGBoost, and now here our model will be XGB regressor. Okay, random state is same, n jobs is 4. So we see that XGBoost is really fast, and it's also giving fold 0 score, which is much better than the random forest score with default parameters. So we are just going to use it for now. So we saved all our predictions and final predictions. I'll go through the code one more time. And final predictions is a list of values. How much test data do we have? We have 200,000 samples in test data, so that's a lot. So what we can do is we can do np.column stack final predictions. Okay, which is actually a list of lists. So this is a list of lists, and np.column stack will convert it to an array. So we have to import numpy2. And let's run this one again. Let's see. So here, see what we get. We get 5 columns and 200,000 samples. So each column is a prediction for the test dataset. So what we can do now here is we can write spreads equal to, or final prediction, or just spreads, and then we can take mean of this axis equal to 1, mean over columns, and these will be your final predictions from all folds. And you can just do some. So let's see our sample submission. So our sample submission has a target, so I can just do sample submission dot target equal to spreads, and sample submission dot to CSV submission dot CSV index equal to false. Remove the index, and here comes our submission file. I will just download it. And now we can go to the competition. 30 days of ML competition. So many notebooks. And my submissions, or sorry, submit predictions. And here I can upload my submission file. So let me drag it. Okay, now it's uploading. So you see you have 10 submissions every day. So you cannot submit more than 10 times, and that's a lot of submissions. So it's still uploading. And in the meantime, I can explain you the code. So what's happening? First of all, we created the folds. Then we extracted the features that we want to use. ID, target, and KFold are not the features that we want to use. We have the object columns, and we also converted our test data frame to useful features only. We don't change the order of test data frame. That's very important if you want to like make submission file this way. And we go through each and every fold, and whenever we iterate through all the folds, our training data is all the data that is not that fold, and our validation data is that fold. And we also make a copy of the test, and we have the training targets, we have the validation targets, we have the training data with useful features, validation data with useful features. We have the ordinal encoder initialized each time for one new ordinal encoder for each fold. And in each fold, we do the encoding. We do fit underscore transform for the training data. This is very important. You don't have to do fit transform or validation or test set. Otherwise, you're not going to get good results. You're going to, it's wrong. So you always fit on the training set and you transform the validation or test set. And now you have the model, XGBoost regressor model. You fit the model, you calculate predictions on the validation set, you print the RMSE on the validation set, and you calculate predictions on the test set, and you save them in a list. So in each iteration, I'm training a new model, I'm calculating the scores, and these are my scores, and you see these are like really very close to each other. That means our folds are good. And then I will take mean of all the predictions. So actually I have 5 different models trained on different subsets of data. And now I take the mean, and that's my mean. That mean is used in my submission file. So let me see, did it finish? Yeah, but okay, it finished the upload, and now we can submit to the competition. And let's see, we get 72138. And if I go to the leaderboard, I'm getting rank 6 at the moment. The competition has just started. Okay. So one more thing to remember is the leaderboard is calculated with approximately 25% of the data. So you have 200,000 samples, it's calculated with just 25% of that, 50,000 samples. The final results are on 150,000 samples, and this result is not shown here. You see the result of only the 25% data. If you go to private leaderboard, it's locked, and it will unlock when competition ends. So now I got 0.721. There is a little bit of difference, but the difference is very little. So I have to see, okay, this is around 0.723, 0.724, the mean of this, and the score is 0.721, which is fine. So now you're done with day 1. Now in day 2, we are going to convert this code to a more readable format so that we can use it in future very easily. And I will publish this notebook so you can find it on the competition page, on the code page. So I hope you like the video, and try it on your own. Don't copy paste. Write the code on your own and try it on your own. Submit to the competition and see what score you get. And see you the next day. And if you like the video, do click on the like button, do subscribe, tell your friends about it, and bye bye.